Hello everybody, and welcome to our lesson on Introduction to Integrals. In this lesson, we're going to be talking about sections 18A through D in your textbook, but we're going to be jumping around a little bit. So we're going to be considering integral calculus, and integral calculus involves antidifferentiation. So that's the opposite of differentiating. In other words, we spent this long learning how to take derivatives and apply derivatives, and now we're going to do the opposite. We're going to start with the derivative and work back to the original function. Integral calculus, we learn it because it has many useful applications, including finding the areas between curves, finding volumes of revolutions, finding distances traveled if we know the velocity function, and sometimes these other things. The ones that we're going to focus on in this course are finding areas between curve boundaries, and we may talk a little bit about distances traveled from velocity functions. So first, let's talk about what antidifferentiation is. The process of antidifferentiation is going backwards from the derivative to the original function. Okay, so if we start with the original function, we can take the derivative to get to dy by dx, or f prime of x. In antidifferentiation, we're starting with the derivative and we're going back to the original function. Okay, so in general, we use this symbol called the integral symbol, and it says that if f prime of x, capital F prime of x, is equal to f of x, then the integral of f of x equals capital F of x plus c. It just means this is the derivative and I'm taking the integral of it, so I'm going back to the original function. Now, there's always a plus c when we take our integral, and that's because we know that when we take the derivative, any constants become 0. So we have to consider that there may be a constant that we weren't considering when we took the integral. That'll be more clear as we do some examples. Okay, so just as a little investigation, I usually do this with my class. You can take some time, pause the video now and try it. If my function is x, if that's the derivative, what was the original function that I took the derivative of to get this? So for x, it's 1/2 x squared plus c. We notice that if we took the derivative of 1/2 x squared plus c, we'd go back, we get the answer, which is x. Likewise, if I wanted to end up with x squared as my derivative, I'd have to start with a function that had x cubed, because if I took the derivative of x cubed, I would get 3x squared, so I'd end up with my proper exponent. But I'd have a 3 in front, so I'd have to divide out that 3. That's why I add this factor of 1/3. And there's always a possibility that there's a constant that I'm not accounting for, so I have to add the plus c. Likewise, if I wanted to have a derivative that was x cubed, I'd have to start with 1/4 x to the 4th. Okay, because when I take the derivative of x to the 4th, that would give me 4x cubed. So I'd have the x cubed part, but I'd have to divide out the 4. So I do that by having a factor in my original function. In general, hopefully you can see that for a function, f of x, it's the derivative. If we want a derivative to equal x to the n, the original function has to be 1/n plus 1 times x to the n plus 1 plus c. So that's our first derivative rule. Our first antiderivative rule. Okay, so if I want to find the antiderivative of x to the 10, then I would have to I'd want to start with x to the 11, and I'd have to divide out that 11 that would come out, the factor of 11, so I'm going to multiply by 1/11. Okay, so 1/11 times x to the 11 plus c. If I took the derivative of this, I'd end up with x to the 10. If I want to end up with 1/x to the 5, remember that that's the same as x to the -5. Applying my rule, the 1/n plus 1 times x to the n plus 1. Okay, if I want to end up with x to the -5, I have to start with x to the -4 and divide out the -1/4. Okay, and last I have this example here. If I want to end up with x to the 3/4, remember I rewrite it first, I'm going to do the same thing. X to the 1/n plus 1 times x to the n plus 1 plus c will give me the antiderivative. In other words, if I take the derivative of this function, I will get this answer.